Over the last year, decision makers have been using the COVID-19 infection rate as a key metric for graduating between phases of increased economic activity. Without additional information beyond positive tests from symptomatic patients, it is difficult to gauge viral expansion within specific regions. One way this is done is by collecting wastewater samples from sewers and treatment plants to test for the presence of the virus. We have been working with our sponsors at Rain Incubator to develop a device that can collect these samples. Currently, the scientists at Rain are collecting these samples themselves, which is both time-consuming and dangerous. We have developed a prototype of an autonomous sampling device that can be deployed into the manhole of a sewer system for long-term and retrieve samples from the sewer without human interaction. The data from these samples can be tracked by scientists remotely so that data readings can be taken more easily and thus more frequently. The device that we have built is powered by a 12-volt, 23 amp-hour DC battery and is controlled by an Arduino Mega 2560 board. The device runs through a 4-stage process to complete the sample collection and is controlled by a set of buttons to navigate through the stages. An LED light indicates the mode that you are in and if the device is busy. There are 4 options to run the device: autonomous, manual, step-through, and settings mode. In autonomous mode, indicated by a blinking red LED, the device sits in the sewer for a specified length of time and takes 3 samples throughout that time frame, without any need for human interaction. In manual mode, indicated by a green LED, you can control each motorized piece of the device freely. In step-through mode, indicated by a yellow LED, you can use the buttons to access each stage of the process independently. And finally, in settings mode, indicated by a purple LED, the user can set the time and date of the device, as well as the location and time of day to take the samples. Both the manual and step-through mode are designed to aid in testing of the device, while autonomous and settings mode are designed for the intended use of the device while being left in the sewer. At any time, the user can press the red reset button to reset the device and choose a different mode. The first stage is the conveyor lift system. It is run on a 12-volt, 16 RPM worm gear motor and uses a 25-pound magnet with a half-inch diameter chrome steel ball bearing to carry the sample collector from the sample tube and down into the sewer water for a specified amount of time. Once the sample has been collected, the conveyor brings the sample collector back up and into the sample tube. In this video, we have used a gauze material to act as a mesh to collect the sample. However, the client can use any material that they see fit. The sample tube is then carried to the next stage via a rotating disc that is powered by a mini 12-volt DC 3.5 RPM motor. The second stage is the preservative pump. After the sample is collected, a preservative is added to the tube with a 12-volt DC peristaltic liquid pump. From there, the sample tube moves to the place cap stage. This part of the device was created using 3D design and printing techniques. It uses a 5-volt DC SG90 servo motor to drop the cap and then slide the cap over the sample tube. The last stage is the cap sealing stage. It is run on a 12-volt 2-inch stroke linear actuator motor and uses 2 micro limit switches to ensure the extension does not go beyond the necessary stroke. Once the current sample tube has reached this final stage, the next sample tube will be lined up and ready to begin a new cycle. This continues for a total of 3 samples. The user can interact with the device using the Blink app, available on the Apple App Store and Google Play. Data relating to the sample is sent to the user's cell phone after each sample is taken, including time, date, location, temperature, and humidity. Although this device is a prototype design, it can easily be expanded to a full-scale device ready to be deployed into the sewer by making a few adjustments. The conveyor can be extended for the length of the sewer chosen for sampling. The casing for the device can be updated to waterproof materials, and the wiring can be soldered. The effects of COVID-19 have impacted all of our lives in one way or another. We feel so proud to have successfully developed this prototype device that once further expanded will have such a positive impact on the future of tracking diseases.